Well, hello everybody, and today we're going to be covering how to create an entity resolver from the SNOMED graph of medical terms. We are going to be based on the SNOMED CT version, the latest version from 2019, if I'm correct, and then we'll kind of transform the raw formats a little bit, get our own format to be able to feed it to our Spark NLP pipeline, and then be able to make some entity resolution on top of standard clinical notes that we will be scraping from the internet. Let's begin. Let's first. We were going to be working on Colab the whole session. So let's start our session in Colab. Let's create a notebook and let's name it SNOMED entity resolution with Spark NLP. Enter price. First of all, we're gonna be loading some credential files that we need, and we will be doing so by mounting our own drive uh, file system on this Colab. So let's quickly bring our code. We're gonna tell it where our notebook data is gonna be, and the way to parse some keys that we're going to provide it through the Google Drive file system, and also the way to start installing everything that we need. We will start by installing Java. Once Java is installed, we will be setting up some environment variables. We will be going ahead and installing Spark NLP, Enterprise, and of course open source, along with PySpark. And now let's do all the imports and all the Spark session starting up. Now that we have done all of our setting up and preparation of our server, we will go ahead and start changing the data that we have about SNOMED here in our drive and put it in a format that we can use it to train uh, an entity resolution model. So now we're going to be training an entity resolver model, and we will be assuming we have our SNOMED CT dataset, as we do have it in our drive file system, and then we will use these dataset or this set of data sets to create our own dataset in our own format with our own schema better, and provide it to Spark NLP and train an entity resolution model on top of that. So first things first, we'll load the data, try to filter it to its latest version, and then do some formatting on it. Where do we read it from? We have some file names, as you can see, and we are gonna read it as Spark data frames. let's get let's filter, as I said, just the valid concepts in their latest versions by using just some SQL, right? uh, every node is going to have just one parent. So every node is gonna have just one parent. Once we've done these, we do some, let's try to do some persistent in order to speed up things, downstream. uh, let's of course let's first uh, per system, and then reload it, kind of to access disk directly. Let's make some counts just to have an idea or of the number of concepts that we're dealing with. And let's keep going. As I mentioned, SNOMED CT is a graph. So what we're gonna do is, based on the filter that we just did before, of course, on where each node has just one parent, one is a parent relationship, um, we're gonna be filtering and creating a hierarchy and kind of flattening that hierarchy, or rather than flattening, creating a tabular structure of that hierarchy, right? So in here, we're gonna grab like the top nodes of the graph of the hierarchy, right? And then just get their descriptions and have like that in one single table called hierarchies. And then we're gonna try to start building the graph downstream, right? In order to go one level at a time, right? So we're building kind of a loop in which we go node by node, child by child, right? Level by level, child by child. Once all of once all of this is done, since it's gonna take a time, let's persist it. Uh, Once all of these data transformations are done, first filtering and then the transformations, when everything is done, we will be back and we will be seeing the schema and basically what we got out of all of this processing. All right, we're back, and we have already calculated everything. We have our numbers over here. We have around 800,000 concepts, uh, or different, no, actually 800,000 different ways of writing concepts, 800,000 different ways of writing 357,406 different concepts. Uh, we also have our tree, or data frame representing a tree over here called all levels right, and we can see the schema over here, basically the concept of the concept ID, its parent, its direct parent. This is what creates the graph. Then kind of a direct mapping of the top parent, meaning one of the top level hierarchies, the level with respect to that top level hierarchy, and then term and top term, basically the description of the concept and the description of the top parent ID. That's what we have in all levels, right? And that's what we're going to use to train our entity resolver in just a moment. Uh, right now, we can see how many SNOMED concepts we're covering at all. And we can see that we have built a graph with just the is-a relationship, kind of to keep things simple. So now we're going to see how much coverage do we have with this way of building the tree. As I just mentioned, we're using the is-a relationship to build the tree. And let's see how many concepts we really covered by going node by node, level by level. So we have almost 94% of coverage. So let's use these for now. We will handle that 6% later. Let's use these, to train a new model, a new entity resolver model on SNOMED, at least on 94% of SNOMED. All right. Let's train it first by creating. Okay, reading first the data and creating the pipeline next. We're gonna have some word embeddings over here and some simple document assembly and tokenization pipeline over here. Okay, something that we need to pay attention to is that doc to chunk annotator here that basically transforms the whole document, in this case a SNOMED concept, into a chunk type annotation, just to be able to train our entity resolver on top of this column, because our entity resolver is based on chunks. Okay, so let's do the training, and let's also do the evaluation and maybe some persisting already, to kind of cache things and do not force resources too much. Okay, let's get our data ready to train our entity resolution model. This is gonna take a moment. At least embeddings are a little bit resource intensive, so I think we'll be right back in a couple of minutes. So we're back, and we can see how this ends up looking by, for example, looking at the distribution over top term column of our data frame. Uh, Actually, let's see these. Whoa. So okay, mainly finding by side procedure, body structure, and so on. Um, Given the way we built this, we basically built this by separating finding in different branches. But let's do this. Let's aggregate all of these, and let's filter the findings and create an entity resolver based on all these findings data set. We'll be right back. How to do this? We basically, let's just filter this by top term, top term, uh, ends string ends with finding. Let's just use like this. Let's see, we're interested in those top nodes. They're gonna be based on only on those, right? Yeah, that's enough. Okay, so based on these, let's create our data frame. Uh, Probably let's comment on these and let's comment on these. Now, based on concepts embedded, let's filter all of the uh, concepts that are part of at least one of these nodes that we selected. And we're back. So now we have all our data in training set, and we can, for example, see its columns. Uh, oh, we can, for example, see its columns, and we have everything ready for this to be trained. For this to train a chunk entity resolver. This term over here is the normalized term. This term over here is the preprocessed term, the one that is going through all this pipeline at the end, becoming tokens and chunk embeddings. So let's create our entity resolver, which is going to look something like this. Yeah, let's execute it and let's train it. Uh, on these data set that we have already selected, the training set. So our fit is going to look something like this. We'll be back once this is trained. Well, the code to train the entity resolvers looks exactly like this, and we're just going to fit this estimator with the data set that we just created. We'll be right back once the model is trained. Okay, our entity resolver is trained, and we can now proceed to our last part of the session, which is going to be kind of testing the entity resolver that we have just trained with some real world data. Um, so yeah, let's just create some nodes out of some URLs that I just scraped from the internet. I'll just paste them right here as an HTML output just for reference. And you know, besides the pipeline that we have already created, we will be using an extra powerful model, an extra model that is very powerful, that is called a named entity resolver. So let's use the named entity resolver that we call clinical NER on top of this new data that we're going to call just nodes data set, right? Let's create our Spark data frame, and then let's adjust the input column name for the document assembler and create a named entity resolver and its NER converter, to create chunks out of the token tags that the NER model provides. Once we have our pipeline, it's just a matter of running the pipeline, creating the Spark ML pipeline and running it on top of our dataset. So let's create our pipeline, fit our dataset of nodes, and also perform the transformation. And let's see how these nodes receive all the annotations that Spark NLP automatically performs. this is kind of how it looks to automatically tag your documents with different, in this case, problems or treatments or procedures or drugs or even risk factors. All of this is possible to recognize in freeform text with Spark NLP and Spark NLP Enterprise, and you will be able to standardize, normalize, and basically resolve and deduplicate any variation of a concept, in this case, a clinical concept contained in SNOMED CT. Thank you very much for joining and hope to see you again next time.